you have, and from a vector standpoint, so I'll go to physics to just start off with, is that you have a horizontal component and a vertical component. So that's why you have equations that are in terms of x and in terms of y. And it's all based upon a parameter t, because typically your horizontal distance and your vertical distance change as time progresses. And typically they're not always the same equation. And so what you'll see is, you'll start to see it with vector form, right? Is, well, we're going to start changing your independent variable to being time. For today and the rest of this week, all we're looking at is just how to manipulate parametric equations. So then when we go to vectors, I have a position vector. I then can have a velocity vector and an acceleration vector. We don't get too heavy into physics. We really just get surface level physics with changing things to component form. I will show you guys some I and J vector stuff when we do it, but not a whole lot, only so then that way you guys get a little bit of exposure if you were to take physics 4A, if you haven't done it already. Because they will expect that calculus has shown you some of that stuff. So I typically try to show you guys stuff that I think that a basic physics class would require you to know from calculus, or what a Math 77 class would require of you. Okay, so super nice and easy to start off with. I want to eliminate the parameter. A rectangular equation is also called a Cartesian equation, which really what I'm trying to do is just turn everything into x's and y's. I want one equation with x and y. So just like what you would probably think you were supposed to do, I would take my x equation and I would solve it for t. And then I would plug it into y. That's it. So I get y is equal to x over 2 squared minus 1. The beauty of this is that nobody cares about simplification. So this is a free response unit. The next unit is also a free response unit. The next time you'll see a multiple choice anything will be with your midterm. Okay. You won't see multiple choice for either one of these units. Not too bad with example 1. Any questions with example 1? Example 2 requires some effort. It requires you to know or remember that sine squared plus cosine squared is equal to 1. So to eliminate the parameter, I'm going to take my x is equal to 2 cosine of t, and I'm going to solve for cosine of t. So I get cosine of t is equal to x over 2. I'm going to then take my y equation. Y is equal to 2 sine of t. So then sine of t is equal to y over 2. And then now I'm going to plug this into my sine and my cosine. So I have y over 2 squared. And then I have x over 2 squared. And I'm equal to 1. And realistically, I eliminated the parameter. Now, it kind of looks like a mess, but technically, if you box this, I can't mark you wrong, because you did what the question was asking you to do. I did not say eliminate the parameter and simplify. I said eliminate the parameter, which is different. So technically, I can leave it like this. If I were to graph this, because I know Jacob's going to wonder, if I graph this, you know what a graph this looks like? Circle. Circle with a radius of 2. Take the square root of 4. Well, it'll be 4 because I have to, the common denominator is 4. You take the square root of the denominator, and that's your radius. Yes. A variable.
Okay.
So like X and Y.
Yes. But if I want to eliminate a parameter, I am eliminating the variable that is in common between the two equations.
So T.
So T.
So like what's a parametric equation?
Thank you.
A parametric equation is, parametric equations in general are equations that are written that have a common parameter. So I could write an equation for X and an equation for Y, but they will only be a parametric equation if they were using the same variable as T. So it has to have a common parameter in them. And I could do X, Y, and Z if we wanted to go three-dimensional, but then in order for those to be parametric equations, all the equations individually would have to be in terms of T. So it'd be an X of T, a Y of T, and a Z of T. Yes, Jacob?
So you're using the same descriptor to find out different aspects?
Correct.
Okay.
Because each distance is modeled by a different equation. So my horizontal distance could be modeled by a different equation than my vertical distance, which also means that they can be growing at a different rate. Good questions. All very good questions. Okay. So I think you can understand how I can get a dy dx from a dy dt and a dx dt, right? Because I can, in order for me to simplify or to get, so my dy dx is a dy dt divided by a dx dt. That's pretty straightforward because I could take, like you could actually see dt's cancel out, right? If I invert and multiply. That's pretty straightforward. The one that's really hard to understand, and I will have to find the proof because I know, like, Jacob, you're going to want to know. I know that you guys are going to want to know, like, right, where all this stuff is coming from. The hardest one for me to explain is the second derivative because when you glance at it, it does not make any sense at all. So I will find that proof because I did it like 8 years ago when the last group of BC actually cared. And so I will pull that proof for you as to why it has to be a certain way. Because when you glance at it, it does not make any sense. But that's a tomorrow problem, not a today problem. We do the second derivative tomorrow. Okay, so I need to find a dy dx, which means I need to find a dx dt and a dy dt, and then I need to take the quotient of them, right? So I don't care which one you find first. I always find dx dt or whatever is listed first. So that's a 1/2 t to the negative 1/2. I find a dy dt, which if I was smart, I would have taken this as a 1/4 t squared minus 1 and then done my derivatives. I would have simplified my y first. So I get a 1/2 t. And then I divide them. So I get a 1/2 t in the top. That's the hard part, is I always screw this up. And because I took dx dt first, sometimes I put it in the top. So just be careful. My 1/2s cancel out. My rules of exponents tell me that's t to the first minus a negative 1/2. which is t to the 3/2. So dy dx is t to the 3/2 power. Now, what's going to be weird about this, and I saw it somewhere, it's not here. I can ask you, which would be terrible, but I could ask you to write dy dx in terms of x instead of in terms of t, which would require a little bit more effort to, once you get your dy dx, to eliminate the parameter. So these directions just say find dy dx, right? But if I said find dy dx in terms of x, I cannot have t there. I have to have x, which requires a little bit more effort. All it does is require you to resolve this equation. Yes, Jacob.
So the parameter is just the variable both equations have, both functions have in common?
Correct.
Okay.
Yes. Yes.
Would you take the derivative and eliminate the parameter, or the other way around?
Okay, so that's where I know where it is now. It's in your homework. So I was like, I know I saw it because I know I asked for it. So if you look at question 1, right? I made a fatal error because I thought, oh, I'm going to be super smart. I'm going to eliminate the parameter first. That was like the most colossal mistake I could have possibly made. So when you look at question 1 on your problem set,
Yeah.
it says find dy dx as a function of x. Don't eliminate the parameter first. Find your dy dx first, like what we did here, and then eliminate the parameter. It turned into like a horrific chain rule thing.
But
And then I actually did not, when I did it by eliminating the parameter first, I didn't get the answer for the problem where I pulled it from. Because I pulled it from a specific curriculum, and I didn't get the same answer. And I was like, that was a colossal waste of time. And then I was like, no, I'm stupid. I could have done this a lot faster. Yes.
Is there a way to know like which one you should do first, or you just have to try it?
I think, from what I can see, it is better for you guys to find dy dx first and then eliminate the parameter afterwards. Because otherwise what happens is that when you eliminate the parameter first, you will always create yourself a chain rule situation, which is going to make it into a big, huge mess. So, all right. I knew I saw it somewhere. I was like, it's not on my paper right here. Okay. So, the only other thing you have to do in this section is write the equation of the tangent line. To do that, first thing is that I would need x at the value, right, of t. So I want x of pi over 2. I also need, give myself a little bit of space, I need y of pi over 2. Because remember, for an equation of the tangent line, I need a coordinate point and the derivative. And then I would need a dy dx evaluated at t is equal to pi over 2. So all of that is what I need. My x of pi over 2 is e to the 2 times pi over 2, which is e to the pi. Like transcendental much. And then y of pi over 2, cosine of pi over 2, which is kind of nice because it's 0. My dy dx, so I need to find an x prime of t. So that is 2e to the 2t.
That's changeable, right?
Yep. So then x prime of pi over 2 is 2e to the 2 times pi over 2, which is 2e to the pi. I need a y prime of t. We just cosine. So negative sine of t, so y prime of pi over 2 is negative sine of pi over 2, which is negative 1. So then dy dx evaluated at t is pi over 2 is negative 1 in the top and 2e to the pi in the denominator. And I just need to write the equation of the tangent line. So y minus 0 is equal to negative 1 over 2 e to the pi x minus e to the pi. And again, like, you might want to get rid of the 0. You may not want to put the 0, but if you put the 0 and you left it like that, nobody cares. Okay. Questions?